Hello and welcome everybody. I am Mr. Athar and today I am going to solve Physics IGCSE 0625 paper 22 for October November 2024. This is multiple choice exam. Let's start guys. Question number 2 first is two forces with a magnitudes F1 and F2 are acting on an object. When these forces are acting, these forces are perpendicular right angle to each other. Find their resultant force. We know that whenever two forces are right angle to each other, we can see the forces are making a right triangle and their resultant can be simply found by Pythagorean. And you know, Pythagorean says that the hypotenuse, that is Fr here, resultant force, will be equal to square root of adjacent square, that is F1 square plus F2 square, and this option is A. So you have to remember for right angle forces, resultant force is calculated by Pythagorean rule. So this is a very important to remember. Okay. Question number 2 here is we have a boy that takes 30 minutes and in 30 minutes the cycle covers 8 kilometer distance. Then he walks a further distance of 2 kilometers in 15 minutes. We are asked to find average speed. So we remember that the speed is always equal to distance over time taken. So here we are asked for the speed, so we can simply say speed is equal to total distance traveled, that is 8 kilometers plus 2 kilometers over the total time 30 minutes and 15 minutes. But you have to remember that these are the minutes, and to convert minutes into hours we need to divide by 60. So total minutes, for example, I can write here 30 plus 15 and I will divide it by 60. So what I got here, 10 kilometers over 45 divided by 60 hours. Now when I try to calculate it, I can get 10 kilometers over 45 divided by 60 is 3 over 4. That can also be 0.75. So 10 divided by 0.75 hours, that is 10 divided by 0.75, so this comes 13.33, and when we round this 13.33 it will give us 13 kilometers per hour. Question number 3 that is showing us four different graphs is about a small light ball. The word light here is very important because it shows that it's having no mass. So mass is negligible. We are considering the object with very small mass like a feather. It is dropped from the top of the tall building. Which graph shows the speed of the ball changing with the time? First thing first, we said that mass of the ball is negligible. When it will move down, the air resistance will affect. So we have to remember that a resistance will create a drag, and drag will be upward. So this upward will be a drag and downward will be the speed due to gravity. Now, when we drop the ball, the speed will continuously increasing initially. But as we move downward, this speed will increase initially, but the drag from the air resistance will also oppose this speed. So you can say that the drag is going to reduce the rate of increase of speed, mean it will reduce the acceleration. So if you look at the graph number 1, in which it says that as the time is passing, speed is continuously increasing. So speed is increasing at constant rate or at constant acceleration, at constant rate. So when speed is increasing at constant rate, it means that acceleration is a consistent same acceleration. Option B is showing us first increase in speed with a constant rate like the first option, and then it is a constant decrease. First a constant rate increase, then a constant rate decrease. When I move to part C, C graph shows me that the acceleration is reducing because the rate is reducing. So speed increasing, of course, it is speed increase for some time, but you can say the rate is decreasing, rate of increase is decreasing. Why? Because of the drag is reducing it, and after some time that speed becomes here constant. When speed is constant, at this point you can say the ball has downward force of gravity and the drag equal in amount, and at this time we can say gravitational pull and the drag are equal, and the object or the ball will move with a uniform constant speed. We can say that this one is a constant speed, constant speed. So it will not increase neither decrease. So whenever we drop a ball, we just said that it will increase the speed, but the rate of increase of speed will reduce because of the drag, and later on the speed will become constant, and that is our actual choice. Getting to the D first, it shows that speed is reducing and then it is. So it can be something moving upward, not downward. And then when it goes upward, speed becomes zero at a moment. So it is, you can say, unrealistic thing. That is not our option. So we are here that it will be our C choice for this question. Question number 4: which statements about gravitational field strength is not correct? So, first we need to say that gravitational field strength is similar to or equivalent to gravitational acceleration. More the gravitational acceleration, more is the gravitational field, and this gravitational acceleration is inversely proportional to the distance. So as the distance increases, gravitational field strength decreases. So it does not depend on the mass of the object, but it depends on the distance. So First option is it changes with the mass of an object. No, it's not true. It is equivalent to acceleration of free fall that we call g. Its unit is Newton per kilogram. Yes, of course, because you know that g is weight over mass, so that is it. Its magnitude is different on different planets. Yes, of course, it is also true, because as we have different planets or we are moving away from the earth, it changes as well. So our correct choice for this option is question is option 4. Moving to question number 5 here. Question number 5 is about the density. We have three liquids, P, Q, and R, have different densities, but they are not mixed up. The liquids are placed in a measuring cylinder and allowed to settle. A small block then dropped into the measuring cylinder and comes to rest as shown in the figure. Before I move for the options, we know that why an object sink or why an object float. This is something we have to remember whenever we have an object that is an object sink when it has density less than the liquid, less than the liquid density in which it is being poured. How it is floats when it has more denser than the liquid within which we are trying to put it, more than the liquid. Okay, now if you look at this diagram, this is our block, and this block is sanked in R, and it is also sanked until the bottom of Q. So we can say that density of the block for sure is greater than density of liquid R and density of liquid Q. But here density of the block is less than density of the liquid P. Now, which statement about the density of the block is correct? As we wrote some notes here, according to those notes, we can see the density of the block is equal to the density of liquid Q. No, we said that liquid Q is less dense, so it is false. Density of the block is greater than P. We wrote that no, block is less than P. So this is less. No, it is less. This is also density of the Q equal. No, block density of the Q is less than the block. It is greater than the density of R. Yes, it is greater than the density of R and Q. Yes, it is. And it is less than the density of Q. No, it is more than the density of Q. So density of the block is more. So our right choice here is option C. Question number 6. The diagram shows a uniform beam pivoted at its center. A student applies two forces, F1 at this point and F2 at this point, and this is the pivot point. Now, which row is correct for clockwise movement about the pivot and for anti-clockwise movement. We know that the moment of forces is always equal to force into perpendicular distance. This one is the clockwise movement. So if you look at clockwise movement, so this is equal to clockwise movement will be equal to the force F2 times the distance d4. Wherever at this other point, the force F1 will turn into anti-clockwise, and this counterclockwise movement will be equal to the force applied at this point. What is that force? This is F1. So you can say F1 times the distance from this point to the pivot is this D3. So you can say F1 times D3. So the right choice here is for clockwise movement we choose F2D4. So either it is C or D. Whereas when you are talking about counterclockwise movement, it is F1D3, that is option D. So our right choice here is option D. Let us move to question number 7. What is this question 7 about? Which expression can be used to determine the impulse on the tennis ball? If I would like to remind you, impulse is a large force acting on an object for short time. That is a force for short time interval. So if I would like to write the symbolical equation, I can say that force into delta T. So that correct option obviously is A. But there is another thing. We also know impulse is also equal to change in momentum, that is delta P. So there is no option that gives us change in momentum. We can also say that it can be mass times change in velocity, and mass time initial velocity is there but not change in velocity there. Mass time acceleration is a force, so this is also false. Now if you talk about impulse as a change in momentum, so we can also say that there is another equation for this. We know that force is equal to rate of change in momentum. So if I say change in momentum is impulse, so that also gives us that it is force into time. So all of these explanation giving us right choice as A. Which row shows the process by which energy in the sun is released? First of all, in the sun, hydrogen nuclei are fusing to form a helium nuclei, and it releases a huge amount of energy. So here you can say two hydrogen nuclei or atom fuse together, fuse to give huge energy plus helium nuclei. Okay, so first thing, that sun is releasing the energy, the process will be fusion, not fission. Second thing, by which process it is transferred to the earth. The radiations are the main source that carry energy from the sun or thermal energy from the sun toward the earth, because we don't have any material inside the space. So electromagnetic radiations, which are in the form of thermal radiations, are reaching. So here we have the second option, squeezed to B or the D. Third is a way in which it is stored when it reaches to the earth. When it reaches to the earth, it's stored in the form of biofuel, not the nuclear fuel. So our final choice should be D. Moving to question number 9, an object has a mass of 20 kilogram. It is taken upstairs through a height of 4 meter. What is increase in stored gravitational potential energy? So, gravitational potential energy stored is equal to mass times gravitational acceleration times the height. When we substitute the values here, we have mass of object 20 kilogram, gravity 9.8 meter per second, and height is 4.0 meter. So this is around 4 times 20 is 80 times 9.8, that gives me 784, and the joule is unit 784 joule. When we round up, we have it in two significant figure, 780 joules. Question number 10, an electrician uses a lifting machine as shown. The lifting machine takes 4.5 second time to lift a vertical height of 3.2 meter. Let me mention time as t and height as h. The mass of the electrician is 72 kilogram. Let me mention it as m. The energy for lifting machine supplied is 2 kilowatt. This is, you can say, power input. So input provided by the machine is 2 kilowatt, and in watts, 1 kilo means 1000. So you can say 2 kilowatt as 2000 watts. This is to remember that 2000 watts is the input. Now question says, what is the efficiency of lifting machine? We have to remember that efficiency is always output power over input power. So output power over input power. Input power is given. Input power we are given by 2000 watt, but to find output power we need to go to the equation of the power. Power out is equal to energy delivered per unit time. Wherever when something is lifted up, the energy is potential energy. When energy is potential, and potential energy, we are very well aware, can be calculated by mass times gravity times height, and we have to divide it by time. So mass of the person that will be lifted is 72, gravity is 9.8, and height is 3.2, whereas the time we have is 4.5 seconds. When I use this, so I can say 72 times 9.8 times 3.2 divided by 4.5, I got 501.76. So in I will keep it as fraction. So in fraction it is 112,544 over 25. Now, getting back to the main equation, efficiency that can be represented sometime by eta is equal to output power is 12,544 by 25 divided by the input power is 2000 watt. So I'm going to divide it by 2000. It gives me 0.25088. 0.25088, and that is approximated to 0.25 into significant figure, and this is efficiency. It does not have any unit. Why it does not have unit? Because it is output power, that is in watt, and input power, that is also in watts. Moving to question number 11. Some altimeters use the change in air pressure to measure the height. The word change is very important. Change in air pressure means final pressure minus initial pressure. If the pressure is 100 kilopascal at the sea level and a particular day, what will be the pressure at the top of the 830 meter hill? So the height is found by change in pressure. It means this height is actually found by the difference of the two pressures, P final minus pressure initial. Let us find the pressure at this height first, then we will see what is the change in pressure. So to find the pressure, we know that pressure is always equal to, for a fluid, pressure is equal to density times gravity times the height. So pressure at this height, let me call it P2 at that height, and this is the initial pressure, let's say P1. So P2 is density, we know that 1.3, gravity 9.8 meter per second, and height is 830 meters. So pressure at height 830 meter will be 1.3 times 9.8 times 830, and it is 10,574.2. 10,574, you can say, Pascal. If we want to convert into kilopascals, I divide by 1000. When I divide it by 1000, it becomes 10.57 kilopascal. Okay, this is the pressure uh, of the air at 830 meter high hill. So this height is obtained by the change in pressure, and we know that change in pressure is usually calculated by final pressure minus initial pressure. So final pressure is 10.6 kilopascal minus initial pressure is 100. You can say, or we can say, 100 kilopascal. Uh, the change in pressure can be calculated by the change in pressure can be calculated by high pressure minus low pressure. High pressure is 100 kilopascal, that is at the sea level, where the at the height it is 10.6 kilopascal. So when you subtract 100 minus 10.6, so it gives me 89.4 kilopascal, and in two significant figure 89.4 will be converted into 89 kilopascal. Question number 12. Water can exist in three state: solid, that is ice; liquid, that is water; and gas, in terms of steam. In which state the motion of the water particle is only vibration? Here we need to understand one thing, that in solid state the molecules are very closely packed, so they cannot move in free state. So in solid, the molecules just vibrate, they cannot move. Whereas in liquid, molecule carry the energy and convection process can be seen. In gases, convection and also radiation process can be seen, but vibration is only in the form of conduction when heat transfers. So we can say that it is only ice state in which the motion of the particle is vibratory only. Question number 13 uh, says that we have a cube that is 2 meter long. The cube contains a gas at a pressure of 8,000 Newton per square meter. I can simply say that this is P1, and we can see the cube with each side 2 meter long. I can find the volume V1 for this cube, that is length time width time height. Because it is 2 2 2 length, breadth and height, so I can say it is 8.0 cubic meter. On the other hand, we have another cube that has a 4 meter long side, so its volume can be V2. Again, length time width time height gives us 4, 4, 4, that is 64 cubic meter. Now it contains the same mass and has and gas as the first cube at the same temperature. The relation of the pressure and volume of the gas at same temperature is explained by the Boyle's law. And Boyle's law says that pressure and volume are always product of pressure and volume is always constant, and we can say mathematically P1 V1 is equal to P2 times V2. And here we are asked to find the pressure in the second cube that we labeled as 2. So we can just simply say the first pressure was given by 8,000 times volume was 8 is equal to pressure is unknown whereas volume is 64. So 8,000 times 8 gives us 64,000, divided by 64 it gives us pressure equal to 1,000 Newton per square meter. That is our option A. Question number 14. Which row gives the correct name of each change of state? Gas to liquid. That process when gas particles are converted to the liquid, it is opposite to evaporation. We call it condensation. So either A or liquid to solid. Solidification, we can say, or we can say freezing. So solidification. So D option is excluded from here. Why? Because we have B, condensation and solidification. Now solid to liquid, of course, a liquid ice is melted to convert into liquid water. So B option is a right choice. In an experiment, question number 15, in an experiment to measure a specific heat capacity denoted by C, unit is joule per kilogram per Celsius degree. A block of aluminum is heated and its rise in temperature is measured. The internal energy gained by the block is denoted by delta E. Having the mass m, the rise in temperature is delta T. If I would like to remind you, specific heat is always equal to energy gained divided by mass times the change in temperature. So we can just simply substitute the symbolical symbols that are given. So I will say delta E divided by m times delta T. That is our option C. That is the right choice. Question number 16. Which statement about the transfer of thermal energy is correct? Uh, First of all, thermal energy or heat energy transfers in different materials in different ways, like in solids or metals, it transfers by conduction. In liquids, it is by convection, and through space, it is by radiation. But when it is traveled through the metals, it's a very good conductor. Metal are very good conductor of heat, but every metal has a different conductivity constant. So all metals conduct thermal energy equally. They conduct well, yes, they conduct well, but not equally well. They're not equal. Convection can occur only in liquids, not in solids. Convection occurs in liquid, yes, it is occurred in liquid, because hot liquid is less dense, not more dense, it is less dense than the cold liquid. So this is also wrong. So D might be right. The radiation that transfers thermal energy is a type of electromagnetic radiation. Yes, radiation move from sun to the earth or from hot body to the air are electromagnetic in nature. The number of the wave fronts or the number of wave passing per second through a fixed point is called the frequency. It's not the amplitude, because amplitude is the height or depth of a wave. Frequency, yes, it is number of the wave per unit time. Speed is frequency times the wavelength, or you can also say that speed is distance divided by time, or wavelength divided by the period. So this wavelength is time taken for one wavelength, one wavefront to pass through it. So option B is our chosen. Question 18. An earthquake under the ocean can produce dangerous water wave called tsunami. The table gives the typical data for tsunami. The first column is for the depth in meters, velocity, and wavelength. Students suggest three conclusions. What are those three conclusions? The deeper the ocean, faster the wave. The first one is deeper and the speed per kilometer hour is faster. Yes, it is true. The longer the wavelength, if you see longer wavelength for the first one is faster the wave. Yes, it is faster the wave. Also, it is true. Faster the wave, like in the first case, 948, the higher the frequency. Here we need to remember wavelength and frequency are inversely proportional. It shows that if we have more wavelength, less frequency. So you can see when wave is faster, wavelength is faster, wavelength is longer. For faster, it is longer. Speed is faster, wavelength is longer. It means that if wavelength is longer, so frequency should be shorter, not higher. It should be lesser. So this one is wrong. So the correct option is 1 and 2 only. That is option B. Question number 19. We can see there are wavefront moving toward the harbor wall. The harbor wall has a gap between it, and after the gaps, waves are passed through but bending around the corner. And we know that the bending around the corner is having a special name, bending of waves around waves or wavefront around around corners is diffraction. So we name it diffraction. So bending a wave is a diffraction, not dispersion, not reflection, neither refraction. Question number 22. A ray of light passes from air into the glass. So we can see the incident ray. This one is the incident ray, and the other is refracted ray. Now the question is that we have to find the angles. Incident angle is the angle of incident ray with the normal that can be seen by this one. So incident angle I can be found because this total is 90 degree with the boundary normal is making. So you can say 90 degree minus 50. So incident angle is 40 degrees. Whereas refracted angle from the refracted ray to the normal is 25 degree. So 40 degree, yes, incident, but refracted is 25. So option A. Next question is question number 21. Question number 21 is about the lenses. We have a convex converging lens here having a focal length f, that is from center to point C, and double of the focal length is here. Now the lens produces a real enlarged image. When object is before 2f, we can say that image will be smaller and inverted, but real it will be on the other side. When object is between f and 2f, image will be inverted, real but larger than the object If it is at C, we cannot see the image. At D, it will be virtual. So here it will be, if position is at D, the image will be virtual. At C, we will say no image, or we can sometimes say image is on infinity. B, the image is real, enlarged, and inverted. And on the other hand, A, it is real, yes, but small and inverted. It is real, small, and inverted. So our correct option here is option B. What is the speed of electromagnetic wave? Electromagnetic wave move with the speed of light. So that is same as speed of light, and speed of light, you can say that it is in 3 into 10 to the power 8 meter per second, or you can say 3 into 10 to the power 5 kilometers per second. And here the option C is our right choice. Question 23. The starter in an athletic race fires the starting pistol. There is a wall 60-meter. We can see the distance from this starter to the wall is 60-meter. Now, take the speed of the sound is 330 meter per second. So we know that the rule is speed is equal to distance divided by the time it takes. Distance divided by the time. The question says how long after the pistol does, after firing the pistol, does starter hear the echo? So we are asked to find the time. So rearranging it, we can say time lapse is distance over speed. Distance over speed. Now, here is a very important thing. Speed is given 330. Distance from the starter to the wall is 60 meter. But echo is when sound moves to the wall and then it reflects back toward the starter. So this will be 60 plus 60 meter, that is 120 meter. So distance sound travels is 120 meter with a speed of 330 meter per second. When we have this 120 divided by 330, we can get 0.3636, and 0.3636 is given as option B. Diagram shows magnetic field around a conductor which is carrying a current. We know that when a conductor carries a current, a magnetic field is produced around that conductor. That magnetic field around the conductor depend upon amount of the current inside it, more current, more stronger magnetic field, and also it depends on the distance from the conductor. If you are experience this from closer to the conductor, it will be more stronger, and if you are farther from the conductor, it will be weaker. So here it will be more stronger as compared to there. If we move back to the actual figure, we can say that The current direction is shown by the cross. So it is, you can say, into the paper. Current is into the paper, and from the right hand rule, the direction of the magnetic field is stronger. So here you can see at point A, the difference between the magnetic field lines is small. This is the smaller distance. But as you move to B, the distance between the lines is more, which is further increased at C and further increased at D, showing that more distance between the lines, it is a weaker magnetic field. Also, the distance from the conductor is more, so D will be the weakest. And two identifications I did talk about here. That first one is if the point is closer to the conductor, that will have the stronger effect of magnetic field. Secondly, when we have magnetic lines of forces, where the lines of forces are close to each other, magnetic field will be stronger. Where the lines of forces are weaker to each other, it will be farther to each other, it will be a weaker magnetic field. Question number 25. A positive ion, a positive ion in a vacuum moves at steady speed in a straight line. As you can see, this was the straight line in which it was moving, positive ion. Then what happens? The potential difference is applied in a parallel plate P and Q so that they are oppositely charged. Okay, one of them is positive, another one is negative. When the positive ion enters the region between plate P and Q, it changes the direction as shown. It moves to the plate P. The diagram shows the view from the above. So if you see magnetic field between two plates, it has a very important convention that magnetic field lines always show a uniform magnetic field. Electric field lines show a uniform electric field. Always there is an attraction. Electric field starts from positive to negative plate. Also, electric fields are showing with the straight lines. And secondly, we have a positive ion, and that positive ion is moving toward plate B. It means this plate P is negatively charged, and plate Q obviously repelling the charge. That's why it is positive. Second thing, the electric field lines will start from positive straight toward the negative, not overlapping, not zigzag. These will be straight toward this one. So here the four options are given. That four options have the correct option C. Why? Because A is showing inclined lines, even B is showing inclined lines. D is showing P to Q. It means it shows that P is positive, Q is negative. That does not happen because the charge was moved toward P. So positive, positive cannot be. Whereas this one, P is showing negative, Q is showing positive. So this is our right choice. Question number 26. In a circuit shown, the voltmeter reads 2 volt. A charge of 5 coulomb passes through the resistor in a certain time. How much energy is supplied? If you remember the definition of the potential difference or EMF, it is the energy. supplied by the cell or the battery to a unit positive charge. So you can simply rearrange it that energy will be equal to potential difference provided by the battery times the amount of charge. So here we are asked to find energy that is potential difference 2 volts times 5 coulomb of charge. So the answer will be 10 joule. Question number 27. Which diagram shows the current voltage graph for the filament lamp? First of all, I will start from the figure D. That is, current is constant if voltage is increasing. It can never happen, and we cannot see any time this type of situation. Moving to C. So C is when we have voltage increasing, current is increasing slowly and then it will increase quickly. So this behavior is for semiconductor diodes. So semiconductor diode behave like this. So this is for semiconductor diodes. Moving to B, voltage and current are proportional. So this behavior is called ohmic behavior, and ohmic behavior is usually for the metals that are good conductors. That as voltage increases, the current also increases. Here, I would like to mention one more thing that whenever we have ohmic behavior, so current voltage graph always constant and its gradient is always 1 over the resistance when current is here. Now moving to A, that is our first one uh, option, that is our right choice of the option. This one is showing filament lamp. For filament lamp, we have always a voltage and current. First, voltage, small voltage will give a boost to the large current, but as time passes, the resistance increases because of the heat up, so it will uh, use more voltage with less amount of current. Moving to question number 28, the diagram shows an electric circuit in which we can see there are three ammeters, three resistances of different value, 2 ohm, 3 ohm, and 4 ohm, with a battery that has potential from, you can say, uh, some value. So here is the positive potential, here you can see the negative potential. Now we have to understand one thing. This ammeter, excuse me, this ammeter is attached directly to the battery. So current from the battery moves toward this, and there is this junction. At this junction, this current is divided. Some part will move to this junction and some part will move backward. So it means if this current, let's say I name it I2, and this current I name it I3. So according to current convention, the total current I1 will be divided into two branch currents, I2 plus I3, or you can also say the sum of the both currents I2 and I3 will be equal to I1. So this shows that I2 and I3 may have different values, but I1 will be more than a separate value of I2 and I3 because it is a amount of. For example, I1 is 4 ampere, so it may be 3 ampere and 1 ampere, 2.5 and 1.5, or it may be the different. So here the first option is current reading ammeter A1 is highest. For me, this is correct. Then it moves to the current reading in ammeter A2 is not highest, it is less than A1, A3 is also less than A1. Current in all are same, it is not impossible, so this one is also wrong option. Question number 29 is also a circuit with a switch, high voltage with two resistances R1, R2 in series, or you can say R2, R3 in parallel, and R1 is series. So, first, I would like to talk about this parallel combination of resistances. Their equivalent resistances will be equal to 1 over R effective resistance, or R equivalent will be equal to 1 over R2 plus 1 over R3. This can be simplified into LCM R2 R3, that can be R3 plus R2, and if I reciprocate it, so I will get the equivalent resistance for the parallel combination. Equivalent for the parallel will be equal to R2 times R3 over R2 plus R3. Now this circuit is in series, so you can say the total equivalent resistance for the circuit will be equal to R1 plus R parallel. So this will give me R1 plus R parallel is R2 times R3 over R2 plus R3. So this option is option B, R2 times R3 over this. The rest of the other options are wrong. An electrical engineer has made a pair of components P and Q. The resistance P decreases as the temperature rises. So P resistance decreases as the temperature rises, where Q resistance increases as the temperature rises. So here we have to remember that any material in which resistance decreases with increase in temperature, that component is called a thermistor. This is thermistor. Whereas when uh, resistance increases with the temperature, this is normal thermal resistor, or you can say this is normal resistor. So now we have a normal resistor in which resistance increases, and in thermistor resistance decreases by increasing temperature. Total resistance of P and Q in series remain constant. So it means that if we connect them in series, thermistor and a resistor, we have a constant total amount of resistance when temperature changes. For example, as much thermistor decreases, that much resistance decreases increases, sorry. So it will have the total value same. So if thermistor and resistor initially have 4 ohm, if thermistor reduced to 3, resistor goes to 5. Their sum is 4 plus 4 8, and 3 plus 5 8. Similarly, if thermistor goes to 2 ohm, resistor will go to 6 ohm, their sum will remain the 8. The two components are connected in series with a power source applying constant current. So a power source is applying constant current. Now what statement is true? If the temperature change causes the potential difference across P to double, it is about the potential difference. So potential difference is related to resistance and the current. So here in this question they said one resistance reduces, other increases with the temperature. So uh, also voltage need the current also. So it means potential difference is not only affected by resistance only, also the current. So this cannot be our right choice. The potential difference between the P and potential difference Q do not change with the temperature. They change with the temperature because voltage affected by the resistance and current both. As I told you, potential difference across the component P increases, temperature rise. Potential difference uh, increases with the P. So we can say that V is equal to uh, IR, and R is proportional to the temperature. But here we know that as the temperature increases for the P, it's a thermistor, so it should decrease. Temperature increases, resistance decreases, and resistance decreases will decrease the voltage. The sum of the potential difference. Now it comes to the same statement, because resistance of P plus Q give us the same result. So voltage of P plus Q will give us the same result because they are connected in series. So we know that in series combination, sum of the voltages is equal to the total voltage applied. So it will not change with the change in temperature, as resistances sum is not changing, voltage sum is also not changing. So this is our correct choice for this question. The diagram shows wire XY moving upward in the magnetic field. We can say motion is upward. A current is induced in the wire. The current carrying wire XY experiences a force because of the interaction with the magnetic field. Which row shows the direction of the induced current? So first of all, we need to know the direction of the induced current, and I'm going to draw the magnetic field direction here. The magnetic field is from north to south, uniform always from north to south. Okay, now motion is this, and it is from north to south. We are going to find induced current. So whenever we are going to find induced current, we need to talk about one thing, that what is the direction of the induced current. We use Fleming's right hand rule. What is Fleming's right hand rule? It gives us that we have to stretch our fingers of right hand in such a way that thumb indicates the direction of the motion, the first finger indicates magnetic field, and the middle finger indicates the direction of induced current. So if I stretch my thumb toward the motion, which is upward, and my first finger toward the magnetic field, that is from my left to right, so the middle finger is going toward the screen, from away from me toward the screen, or it is from X to Y. So first thing I will like to draw here, that according to Fleming's right hand rule, we can simply say that the amount of the current, the direction of the current is from X to Y. So I can just simply say direction of the current is from X to Y. So I can say this one, this is from X to Y. So current is from X to Y. Okay, now moving to the direction of the force experience. So there are two ways to talk about the experience force. When current is there and it is induced due to an external magnetic field. So Lenz told us in his Lenz law that the force will be opposing the cause. So cause is the motion which is upward. So according to Lenz, opposing force will be towards, sorry, away from the motion. So Lenz law says it will oppose the cause. So force opposes the cause, and cause is the motion, because motion uh, produce the induced current, opposes the cause, that is motion. So it will be from the Lenz law, it is force is opposite to the motion, that is downward. But we also have another way to talk about the force. when there is an induced current and it is inside the magnetic field. So that is also called motor effect. So we can use left hand rule in this case. In this case, what you have, the force is indicated by the thumb, magnetic field by the first finger, and the current by the middle finger. So current induced is away from me, magnetic field is from my left to right, so force will be downward as I told you. So here in this case I can draw the force to downward direction. So which row shows me both of these? So induced current is from X to Y and the direction of the force is downward. So option A is the right choice. Question number 32. We have a similar type of scenario. We have a bar magnet, and that bar magnet is getting into a coil, and this coil is connected to center zero sensitive voltmeter. Center zero sensitive voltmeter, if there is no current, so it will be pointed toward the center that is showing zero. There is one more thing. If a bar magnet is stationary, so of course there will be no current induced in the coil. But if bar magnet is moving toward or into the coil, it will have a current induced. And when it is leaving the coil or out of the coil, it will have another direction. So if in the beginning it was to the left side, it may be the anti-clockwise rotation. So when it will leave, it will be a clockwise rotation of the current. So when the bar magnet is getting in, if the current produces clockwise, when it is getting out, it will produce anti-clockwise rotation of the current. So here in this case, diagram 2 shows no current and diagram 3 shows current in opposite direction. So here we are asked that which direction of the pointer of voltmeter at diagram 2 and diagram 3. Diagram 2 is at center 0, either B or C, but diagram 3 is not at center, it is to the opposite to the initial, that was to the right, so we will make it to the left. So our correct option here is option C. What is the purpose of the brushes and split ring commutators in DC motor? DC motor is actually a work on the Faraday's law of electromagnetic induction, that when current passes through a coil, it starts rotation. It is opposite to the opposite to the DC generator. In generator, we provide motion, so it produces current. In a motor, we have the current to rotate it. So, what are the uses or the purposes of the brushes and the split ring? The brushes and the split ring are actually used for the speed. You can say change the size of the current. No current, it will not be changed. Keep the coil turning in the same direction and keep the speed of rotation constant, and to make the output of alternating voltage, this is also wrong. To keep the speed of the rotation constant, it is to keep the turning the coil in the same direction. So question number 34, the diagram shows a beta particle. Beta particle is usually an electron, and electron are having a negative charge. So electron with a negative charge is directed between the poles of a magnet. This is the beta particle. Its velocity is toward this direction. Magnetic field is from north to south. Now, in which direction will particle be deflected? Mean where will it experience the force? To find the force, we use Fleming's right hand rule. So, what is Fleming's right hand rule? Fleming's right hand rule says you have to use your right hand to find the direction of the force on this particle. So when direction of the force to find, you have to stretch your right hand finger in this way, that thumb point out the force, This first finger is magnetic field, middle finger is the direction of the velocity. So first thing first, the direction of the magnetic field from up to down, and velocity is in this direction. So magnetic field, velocity, so thumb is pointing toward me out of the plane of the paper. So it will experience a force due to which this particle will move toward away from the screen or out of the paper or out of the screen. So we can just simply say this is out of the screen. Question number 35. An alpha particle and a beta particle have the same kinetic energy. When they have same kinetic energy, we need to be aware about one thing. You know that kinetic energy is always equal to half mv square, half time mass time velocity square. So for this one, you have to remember, if kinetic energy is same for two objects which are not having same masses, alpha particle is heavier because it is helium nuclei, whereas beta particle is electron and it is lighter, it has less mass. Okay, now they have same kinetic energy, so it means they will have different velocities. So why does alpha particle have larger ionizing effect than beta? So alpha particle has large charge because I told you it's helium nuclei, its charge is 2He4, it's and electron is, you know that it's just one electron, so it has two proton, two neutron, so it is heavier. So alpha particle has heavier and also charge of the two proton, so it is twice the electron. So charge of the alpha particle is two times positive, and charge of the beta particle, which are electron, is half of and negative. So alpha particle is larger charge. Yes, of course, it is larger charge. So A, B both are correct. C, D will be wrong. Now coming to A, B again. Alpha particle is large charge and large velocity. I just told you the mass of the alpha particle is more. So obviously velocity will be less. Mass is more, velocity will be less to get kinetic energy constant because it is our condition, same kinetic energy. So beta particle is not having large velocity, large charge with small velocity. Option B is the right choice. Question number 36. It is related to the half-life time. You have a radioactive source, and the student is going to record the counts in 5 minutes interval, and each time with the source and one time without the source. So you are asked to find average correct count rate for the source. So here we need to talk about corrected count rate. So corrected count rate mean what? What is the meaning of corrected count rate? This count rate is the source. This count rate is the without source, mean it is a background radiation that are always present. So this is background and this is source with background radiation. So background radiation plus source, so I need to subtract to make it correct. So for this one, I am getting 68 minus 25, 43 counts, 73 minus 28, 45 counts, 69 minus that is 47 counts. Now I'm going to find average. So average count rate will be 45 plus 43 plus 47 divided by the 3. So I am getting average count rate of 45 counts per 5 minutes. So 45 counts per 5 minutes. But here in the options, you can say it is giving per minute. So I need to find if I have 45 counts in 5 minutes. So in each minute, I will have 9 counts per minute. So 9 counts per minute is my right choice. We have a count rate measured by radioactive source that drops from 542 to 94 counts per minute in 12 hours. So the background count rates are 30 counts per minute. It was 542, fell into 94. So 542 corrected will be 512, and 94 corrected will be 64. So from 512 to 94, the first half lifetime will make it to 256. I just divide 512 by 2, and second half lifetime will change it to 128, and third half life will change it into, this is 128 divided by 2, 64 counts per minute. So 64 count is coming after three half lives. So we found that there are totally three half lives. So out of those three half lives, what are the total half-life time? So your time for three half-life is 12 hours. So what is half-life time? So 12 hours divided by three number of half-lives, that is 4 hours. So 4 hours is option C. What happens when a protostar becomes a stable star? Stable star mean gravity is balanced. So we can just simply say that most of the hydrogen converted into helium and protostar expand. No, this is not the right choice. The inward force due to gravity is balanced by the outward force. Yes, this is true. Protostar collapse due to gravity and temperature increases. No, it's not converted into fuel. So our option B is the right choice. Second last question is question number 39. What it says about, it is also about the solar system. We have the information of different planets, Earth, Jupiter, Mercury, and Uranus. Their masses, average density, and the gravitational field strength are given. Which statement about these planets is correct? First option is, as the mass compared to the Earth increases. So you can say mass increases for the Jupiter and also for the Uranus. So mass increases. As mass increases, the average density increases. When mass of Earth is 1, density is 5.5, mass is 320, and this is 320 time is not increase, even it is decrease. Same fashion here, it is decrease. So this one is not increasing, it is decreasing. As the mass compared to the Earth increases, like Jupiter and Uranus both increases the mass, the gravitational field strength increases. So mass of the Jupiter is more, gravitational field strength, yes, it is more. For Uranus also, gravitational field strength is more. So it seems to be correct. The average density increases, the gravitational field strength decreases. Density increases, uh, there is not a single one in which density is increasing by the Earth, but let's say I will make it vice versa, that density decreases, gravitational field increases. So density decreases, gravitational field is increasing, not decreasing. This is wrong option. And it says that it is directly, no, it is inversely proportional to this one. So our option B is correct option. Last question is, which quantity estimates the age of the universe? It means you are asked to find time. And for finding the time, we know that first equation, Hubble constant, is V over D. And also there is another equation, that is speed is equal to distance over time. So if you need to find time, so time is equal to distance over speed. So it means that if I flip this d over v, it will also flip the Hubble constant into 1 over ho. That will give us the time of the universe. So time of the universe in this options is option number C. Thank you so much, guys, for your participation. I'm hopeful that you guys understood this well, and it will be I tried my best to make the to solve these exam in easier way, to make you understand well. Thank you so much for now, but please don't forget to subscribe and share my YouTube channel, that I can make more videos for you guys. Thank you so much, and bye bye.